Welcome students to the series of lectures on statistics, and we are currently into continuous probability distribution. We completed the discrete probability distribution, and even in the continuous probability distribution, we completed normal distribution, we completed t-distribution, we completed chi-square distribution, and now we are entering into one of the most used distribution in regression, that is F distribution. Without this, you cannot do ANOVA analysis. So therefore, it is one of the most critical distribution that you have to study, that is F distribution. Now, let's jump directly into F distribution. So I will not convolute the discussion. I will start the discussion with the same rhythm we did with chi-square distribution. So why chi-square distribution? The same way why F distribution when we have normal distribution and t distribution. But the problem with the normal distribution and t distribution is that if you use normal distribution or you use t distribution, the problem is the leftmost tail or the leftmost area or the leftmost region of normal distribution approaches, this tail approaches minus infinity, and the right section approaches or the right tail approaches positive infinity. The same with t distribution, minus infinity till positive infinity, that is the range, negative infinity to positive infinity. But the question is, does entity like stock prices, bond prices follow normal distribution? Does these value go below zero or it goes to negative? No, the answer is no. Similar, the entity like variance, does it go to negative value or does it fall below zero? The answer is no. So we need a distribution which is pegged at zero, and theoretically, definitely the value can go up to infinity. Nobody will stop you because yes, anything, any entity on this planet could be priceless, depends upon the condition of the market, depends upon the condition of the economy or the condition of geopolitical scenario. So yes, theoretically, stock prices can go up to infinity. It can become priceless. It depends upon the condition. But theoretically, stock prices cannot go to negative value or cannot go beyond zero. Definitely, it can go up to zero. Bond prices cannot go to negative value. It can definitely fall to zero. So variance can fall to zero, but cannot go to negative. So you need a distribution which is pegged at zero and go up to infinity in the right direction. So basically, you're interested in distribution which are right skewed distributions. Right skewed distribution. If you do not remember right skewed distribution, then please watch the lecture which is related to movement 3. Okay, what are the different right skewed distribution that we have? The first distribution I would say that we have already discussed is a chi-square distributed variable. The second is log normal. The third is F distribution, F distributed entity or variable. Now the same question that we asked in chi-square distribution, that when we can use F distribution and when we cannot use F distribution. Basically, when we can use chi-square, when we can use log normal, and when we can use F distribution. So we can use F distribution when this condition gets satisfied. This condition gets satisfied. Then only you can use F distribution. This is very similar to what we discussed in the chi-square distribution. Remember, we said that you can only use chi-square distribution if this condition gets satisfied. This condition gets satisfied. What is the condition? It starts with standard normal data. If you haven't watched this video of chi-square distribution, then please watch this video of chi-square distribution. So if the data is standard normal data or follow standard normal distribution, and if you take the sum of square of these standard normal data, if you take the sum of square of standard normal data, that is chi-square distributed. We also discussed in chi-square distribution session that what is the definition of standard normal distribution. That is related to what? Z-score. I'm repeating it for you in F distribution discussion. What is the standard normal data? In a very simple term, you can say this is a Z-score, which is equal to x minus mu upon sigma. Or the correct interpretation of standard normal distribution of data is, first of all, the first condition is it should be normally distributed. The second condition is the mean should be equal to zero. And the third condition is that the standard deviation of variance should be equal to one. If all these conditions are satisfied, then the data is standard normal data. There is another way to understand the standard normal distribution. Let's assume that you have a normal distribution which has a mean of say 2 and the standard deviation of 3. So let's plot it. So there would be a data point called as 5, there would be a data point as 8, there would be a data point as -1, there would be a data point as -4. If I say calculate the z-score for 2, you will say the z-score for 2 is 2 minus 2 upon 3, that is 0. Calculate the z-score for 5, you will say 5 minus 2 upon 3, that would be 1. Calculate it for 8, it would be 2. Calculate it for -1, it would be -1 itself. Calculate it for -4, it would be -2. See, this z-score is also standard normal distributed. So if you calculate the z-score of a data which is normally distributed, that is standard normally distributed. So that is the definition of standard normal data or standard normal variable. But what we are saying, if you take the sum or average, that was a condition for what? Chi-square distribution. But here we are saying you take the average, actually, you take the sum or average of square of standard normal data. That was for chi-square distribution. There's something new we are adding now. If you take the ratio of average of square of standard normal data, if you take the ratio, division ratio of average of squares of standard normal data, that is F distributed. That is a condition. Let's understand what it's saying. So these values are what? Standard normal data. You took the square because it is written, you have to take the square. Then you have to take the average. So you are summing it up and taking the average. So if this is n1 data point, you will divide by n1. You took the average. Then you take the ratio. You took the ratio with what? With the square of or the average of square of other standard normal data. So this y, these y's, y1, y2, y3, yn are what? Standard normal data. What you took? You took the square and then you took the average. If these are n2 data point, you will divide by n2. So you took the average, you took the average, you took the ratio of what? Of the square of the standard normal data. And then it will be F distributed. So this is interpretation number 1. This is interpretation number 1. Now, the same can be interpreted in another way. This is interpretation number 2. Now, I'm asking the question, what is this? What is this distribution? What is this distribution? If you don't remember, let's go to the previous discussion. This is what? Chi-square distributed. So can I write instead of this, can I write this is chi-square distributed? Okay, I've written chi-square distribution. Then I'm dividing by n1. What is n1 here? It is a degree of freedom of chi-square. It is a degree of freedom of chi-square because the number of standard normal variable is n1, and that is the degree of freedom for chi-square distribution. That is what we discussed in the last session. So this is the degree of freedom of chi-square distribution. This is a chi-square distributed entity. This is the degree of freedom. Again, if you look into this value, only this value, the sum of square of standard normal data, this is what? Chi-square distributed. So I've written it as another chi-square distributed entity divided by, see the division, divided by the degree of freedom. Why it is degree of freedom? Because what is the degree of freedom in chi-square distribution? It is the number of standard normal variables. Degree of freedom. If you take the ratio of the two, that is definitely F distributed. There is no difference between interpretation number 1 or interpretation number 2. So if anybody asks you that if you take the ratio of average of chi-square distribution, two different chi-square distribution, that is also F distributed. Now, in the last session, we invested the time to understand that variance approaches chi-square distribution. Variance approaches chi-square distribution. So if you see this section is what? Chi-square distributed. Then you're dividing by the number of entity, which is the degree of freedom for the chi-square distribution. So the variance of any one entity divided by the variance of other entity, variance of x upon y or variance of y upon x, that will be what? F distributed. So the ratio of variance of two entity, will be F distributed. So you cannot use F distribution whenever you like or feel to use it. No, the answer is until unless you're not talking about ratio, you're not talking about the average of, square of, standard normal variable. Till then, you cannot use F distribution. And the most important word here is ratio. So at the end, we discussed, okay, whenever there is a ratio of variance of two different entity, then I can use F distribution. I mentioned in the last session that chi-square distribution should be used whenever you are discussing or testing in your hypothesis testing, discussing or testing the variance, then you will use chi-square distribution. When we were discussing about the mean, when we were discussing about the mean, we said use normal distribution or t distribution. If I summarize everything, F distribution should be used whenever you are measuring ratio of variance, or most important, when you want to compare the variance of two different entity. Whether the variance of this entity is larger than or smaller than the variance of this entity, you will use F distribution. When you are just comparing or testing a variance of unknown and known variance, then you will use chi-square statistics. Okay? When you are just testing the mean, then you will use t distribution or normal distribution. So whenever you're testing mean, it should be normal distribution or t distribution. Whenever you are testing the variance only, then it should be chi-square distribution. Whenever you are testing the variance of two different entity, then it should be F distribution. Now there would be confusion that when to use chi-square distribution then. If you are testing the variance of the population and sample of the same entity, you will use chi-square distribution. When you are testing the variance of two different entity, then you will use F distribution. Okay, this is about when to use F distribution and why F distribution comes into the picture. Now, in the next session, we'll try to understand and read F table, and we'll also try to understand whether F distribution is a single distribution like normal distribution, or it is a family of distribution like chi-square distribution or t distribution. With that, we'll end the session. Thank you. Have a nice day.